Hey guys, welcome back. So what we're looking at today is 6.11, solving right triangles using trigonometric relationships. So let's go ahead and jump right in. Now, there's a lot in this lesson simply because it is the last one of the chapter, and so we're going to have a lot of kind of review going on in it. So just be prepared for that. There is a lot in here, but it's sort of a review of everything we've kind of worked on over the course of this chapter. So based on each set of triangles or parallel lines, create a proportion and solve it, finding the missing values. So we're going to take a look at number 1. So we have this triangle here, and we know 10 and the question mark are going to be in some sort of proportional relationship because we have a small triangle within a larger triangle. So we look at the large triangle. This side here is 12 plus 4, which is 16. So we've got 16 over the long side of the smaller triangle is just the 12. So 16 over 12 equals, well, now we do the base of the big triangle, which was 10, over x. We don't know what the question mark is, so we make it x. Now we can take and solve this proportion. So remember, we cross multiply. So we'd have 16x equals 120. Divide by 16. So x equals 7.5. So that's how we could take and set up our proportions here. We take and set up the larger in comparison to the smaller. We can also set it up different ways depending on the situation. In these cases, setting them up, the large triangle, the small triangle is going to be your best option. Now, 4 and 6 look a little different. They're parallel lines with transversals cutting through them. So these we do set up differently. So here we're going to set up the parts across from each other over one another. Sorry. So we'll have the 6 over 4 equal to x over x minus 2. So then we cross multiply. So we have 4x equals 6x minus 12. Subtract 6x. Subtract 6x. So we end up with a negative 2x equals negative 12. We divide them both by negative 2. So x equals 6. So x equals 6 in this case. So when we have those parallel lines, just set the parts across from one another over each other. So one side over the other, and then cross multiply and solve for your proportions. So proportions is your key word for this lesson, proportions. All right, solving triangles with trigonometric ratios and Pythagorean theorems. So solve each right triangle, give any missing sides and missing angles. So we're going to take a look at number 7. We are missing both angles and one side. So for the side, I'm going to use the Pythagorean theorem. So I'm going to come up here so I have space. So we've got 17 squared plus x squared equals 18 squared. 17 squared is, I believe, 289. Yep, 289 plus x squared equals 18 squared is 324. We subtract the 289. So we have x squared equals 324 minus 289 will give us 35. We take the square root of that, and then we take the square root of 35. We end up with 5.9. So this is 5.9. All right, now in terms of our missing angles, here's where we have to use our trig ratios. So looking at this, I'm going to solve for b first. And we always want to use the side measures that are given to us rather than ones that we've solved for, just because they're more exact. Like this 5.9, it wasn't just 5.9, it was 5.91, so on and so forth. It went on forever. So we want to use the exact values to the 18 and 17. So 17 is opposite, 18 is hypotenuse. So that means we are looking at sine. So sine of B equals 17 over 18. And remember, when we're finding angle measures, we always do the inverse. So this is going to be B equals the inverse sine of 17 over 18. And we plug that straight into our calculators, and we're going to find that it is 70.81 degrees. Now, for angle A, we have adjacent and hypotenuse, so we could do cosine. So we'd have cosine of A equals 17 over 18. That's supposed to be 17. So once again, we do the inverse. So A equals cosine inverse of 17 over 18, which gives us 19.19 degrees. And remember, you can also solve for that one by subtracting the 70.81 from the 90 to find out what that third angle would be. All right, so that's what happens. This is what we have when we don't have any of the angles aside from the 90 given to us. Now, number 11, we're given one of the angles and one of the sides. So it works a little differently in this case. Now, finding the angle is going to be easy. We just take 90 minus 40, which gives us 50. So angle A here is 50 degrees. So finding the angle is nice and easy. Now finding the sides, we have to use our trig ratios for. So we have angle 40 as our reference angle. So we have opposite and we want to find adjacent. We also want to find hypotenuse. So one of our trig ratios will be tangent 40 equals 3 over x. The other one is going to be sine 40 equals 3 over y. So we'll say this is x and this is y. So in both of these situations, the y and the sine 40 or the tangent 40 are going to switch places in order to solve. So we're going to have x equals 3 over tangent 40, and our sine will be y equals 3 over sine 40. Now, we just plug that completely in the calculator, take 3 and divide it by tangent 40, and that is going to give us 3.58. So side x is 3.58. Side y, when we plug in 3 divided by sine of 40, we're going to get 3.92. So you will be finding 3 values for every single one of these. So make sure you have all 3, okay? So whether it's 2 angle measures on one side or one side and 2 angles, it just depends. So keep that in mind. Alrighty, so more using our trig ratios. Here we're using them so we can sketch out a triangle and then finish solving it. So for this, we have cosine of B equals 3 over 5. So we're going to have our triangle. We'll make this B, A, and C. So there's our right angle. Now, if we're doing cosine of B is 3 over 5. 3 is the adjacent. So that would be this side here. 5 is the hypotenuse. So that would go right there. Now, using the Pythagorean theorem, we would have 5 squared is 25. So we'd have 25 equals 9 plus x squared. Subtract the 9. 16 equals x squared. So our missing side is 4. Now for our angle measures, remember, we have to use the inverse sine or cosine. So to find angle B, we can use what's given to us. Just do cosine inverse of 3 over 5, and that's going to give us angle B equals 53.1 degrees. And then, like I've said before, you can always take and use subtraction with the triangle angle sum theorem and take 90 minus 53.1 to get 36.9 degrees for our second angle. So that's what you guys are doing on this section here. You're drawing out that triangle and then showing what the missing parts are. All right, the next part, use the right triangle below to determine which of the following are equivalent. So keep in mind those relationships that we looked at and how I always said, so this one's the same as this, and this one's the same as this, and this one's just the flip. So think back to those. The two I'm gonna do with you are 27 and 29. So 1 equals what? Well, 1 is going to equal sine squared b plus cosine squared b. That's always going to be the case. It's a true relationship. And then Pythagorean theorem, a squared plus b squared equals c squared. So those two match up there. So you're just drawing lines to connect these, okay? So obviously lots of parts there. All right, the last section is looking at sketching a drawing for the situation and then solving. So now we are actually going to solve. So Susan is designing a wheelchair ramp. Wheelchair ramps require a slope that is no more than 1 inch of rise for every 12 inches of ramp length. So 12 inch, 1 inch. Okay. Susan wants to determine how much horizon distance a ramp of 6 feet in length will span. She also wants to know the degree of incline. So here's our y, our angle down here is x. So to solve for x, we have opposite and adjacent, which means we're using tangents. So tan x equals 1 over 12. So remember, use the inverse. X equals the inverse tangent of 1/12. Plug that in and you're going to find it's 4.76 degrees. Now, using that angle, we have the bigger triangle where we've got the 6 and the y. We also have opposite over hypotenuse now, so it's sine of 4.76 equals y over 6. So we have 6 sine of 4.76 equals y. So now we just plug all of this right into the calculator, and we find that it's 0.498 feet. So not quite half a foot. So you have to be very careful with these. With that angle measure, obviously, I told you before, don't ever use the angle you solve for as your angle that you're going to use. But in this case, we have to take and do that. So sometimes that will happen. That's okay if it does. So just be super careful with that, okay? All right, if you guys have any questions, feel free to ask. Have a wonderful day. Bye, guys.